Okay, the brick class. The brick class is also implements sprite. All bricks have a width of 80 pixels and a height of 20 pixels. They've all got an X and Y value. They've all got a color. And a brick can be either alive or dead, because bricks are going to disappear when they die. In the constructor for a brick, it's given X and Y values, so it's placed on the screen somewhere. It's assigned a color. It stores the X and Y value of where it should be on the screen, and it starts out as alive. Since bricks don't move, we don't have to do anything in the update method. When we draw a brick, we draw it the appropriate color, the appropriate location. Now, I drew it with a width -2 and a height -2, and an X value of X plus 1 and a Y value of Y plus 1. What this does is it gives us a nice little space between bricks. You notice the little black lines in between the bricks. This was done just to give me a 2 pixel wide spacing between the bricks. If it's dead, how do we know if a brick is dead? It's dead if it's not alive. So the exclamation point is for not, and so you just return not alive. Get X and get Y. So to find the X value of a brick, we just return X. To find the Y value of a brick, we just return Y. For do hit, so because it's a sprite, we have to have a do hit method. Sprites may interact with the puck. So to see if a brick hits a puck, we get the X and Y and radius of the puck. If the puck is too far left, right, up, or down, then it didn't hit the brick. This is just like, this first part of it is just like the do hit method, the paddle. Which makes sense because both the puck, or both the brick and the paddle are rectangular, right? However, if we don't return, it behaves a little bit differently. Okay, so in the case of a puck hitting a paddle, if the puck hit the paddle, then the puck bounced, and that's all we did. But if a puck hits a brick, we set alive to false. The brick dies, and the puck bounces. And since the brick is passing itself to the puck, we'll end up executing the bounce method that receives a brick as the parameter, and the puck will bounce appropriately for a brick. And that's really all there is to brick. I'm also going to describe falling brick. So the idea here is that falling brick is an extension of the brick class. And I wanted to do this as an example of extending brick because that's your assignment, is because I want you guys to each extend brick in a different way to add other features, create other kinds of bricks, bricks that maybe have to be hit twice to die, or bricks that change color, or maybe they do both. They change color when they get hit the first time, and then the second time when they're hit, they die. Or if you want to go back to your fireworks program, you may want to figure out how to create sparks and have the bricks turn into a bunch of sparks when they get hit, and have the sparks fly out like an explosion. So it'll be up to you to be creative and to extend brick in your own way. So for a falling brick, it needs a Boolean, so it extends brick. It needs a Boolean is falling, and a velocity in the y because it's going to fall. The constructor, super XY. So the falling brick is going to start out by initializing itself just like the brick. So what this does is we can think of falling brick as if it has a brick inside of it, and you have to initialize that brick that's inside of it. And in addition, it's also going to initialize is falling and Vy. So it starts out not falling, and the velocity in the y is false. And then it redefines color. Now, you may want to see a little bit, I guess it's important to note in the brick class that a couple of the variables are protected. In the past, we've already seen public and private. Private means that it's only accessible within the class. Public means it's accessible outside of the class. Protected is somewhere in between public and private. Protected means it's accessible within the class and within the subclasses. So I would not be able to access the color of a brick from inside of the paddle class because the color is protected. But because falling brick extends brick, I can access the color of the brick because the color is protected. The children of the parent can access the protected methods, but they're not accessible from just anywhere outside the class, only from within the subclasses or the children. So I wanted the falling brick to look just a little bit different on the screen than a brick, so I reset the color to something a little bit different. When a falling brick is updated, if it is falling, then change its y value based on its y velocity and increase the y velocity a little bit. If the brick is dead, if its y value is greater than the game height, return true. Remember, the game removes the brick as soon as the isDead method returns true. So we don't really want this method to behave exactly like a brick. Otherwise, it would get removed from the game as soon as it got hit. We don't want it to be removed from the game until it falls off the bottom of the screen. So the isDead method doesn't return true until its y value is greater than the game height. Otherwise, it returns false. The doHit method, if it is falling, it just quits. We don't want the puck to hit and bounce off of falling bricks. But if the brick is not falling, just go ahead and do the doHit method just like the superclass, just like the brick class. So super.doHit and pass it the puck. And then if it is dead, then it is also falling. Okay, so doHit of the parent class will make it dead if the puck has hit it. If it is dead, then it should also be falling. And that's it for the brick and the falling brick classes.